Hey everyone, welcome back. Today, we're diving into a technology that, and I'm not exaggerating, has totally changed the game for anyone who builds software. We are talking about Docker.
Okay, let me paint a picture for you. I bet every single developer out there knows this feeling deep in their soul. You've been working for weeks, maybe even months, on this incredible app. It's perfect. It runs flawlessly on your laptop, you feel like a genius. And then, you hand it off to someone else, and it just explodes. If you're nodding along right now, maybe with a little bit of trauma, then listen up. Because the tool we're breaking down today, Docker, is basically the superhero that was created to stop that exact nightmare from ever happening again.
All right, so let's really lean into this developer's nightmare for a second, because understanding the pain is absolutely key to understanding why Docker is so revolutionary. So let's get really specific. Picture it. You built your app using, I don't know, something a little obscure like Cobalt, and it's all perfectly set up for this very particular kind of quirky version of Linux that you just happen to love.
Awesome, time to share it. But your friend's machine? It's a completely different universe. They're on a different OS, they have different versions of all the software libraries. Their computer is basically a foreign country to your app. And what happens next? Total chaos. Predictable chaos, but still chaos. The app just dies on launch. You get a flood of errors, missing this, wrong version of that. And then comes that dreaded phrase, but it works on my machine. Ugh, it is a soul-crushing waste of time.
So this all boils down to the million-dollar question in software development today. How in the world do you package up an app so that it runs in the exact same environment with the exact same stuff, no matter what computer you put it on?
Well, for a long time, the best answer we had was something called a virtual machine, or a VM. Let's talk about this heavyweight champion for a minute.
A virtual machine is basically a whole computer inside your actual computer. It's like building an entire house just to hang one picture frame. To run your app, you have to pack in a complete, full-blown operating system, all of Windows, all of Linux. And yeah, as you can probably guess, that is crazy heavy, it's slow to start up, and it just devours your computer's memory and processing power.
And this is exactly where Docker strolls onto the scene and completely flips the table with a genius, incredibly efficient solution.
So check this out. This is the core difference right here. A VM has to pretend it has its own hardware and then load a whole new OS on top. But a Docker container, it does something way smarter. It just borrows the core of the operating system, what we call the kernel, from the computer it's already running on. That means it only needs to package the app itself and its dependencies. The result? It's tiny, it's fast, and it's unbelievably efficient. Okay, so we get why it's better, but how does it actually pull this off? Let's get into the nitty-gritty. It really all comes down to three main pieces.
The entire Docker universe boils down to this really simple, elegant flow. You start with a Docker file, which you use to build an image, which you then run as a container. That's it. Let's look at each one. First up, you've got the Docker file. The best way to think of this is like a recipe, or maybe even your app's DNA. It's just a plain text file. And in that file, you write down the instructions, step by step, for building your app's perfect little home. You say, start with this OS, install this software, copy these files over, and then run this command to kick things off. So, you've got your recipe, the Docker file. Now you run a command, and Docker turns that recipe into an image. An image is like a perfectly preserved snapshot of your app and its environment, frozen in time. The magic word here is immutable, which is just a fancy way of saying it cannot be changed, ever. And that's the secret sauce that guarantees it's the same every single time. And last but not least, the container. If the image is the frozen blueprint, the container is that blueprint brought to life. It's the live, running, breathing version of your app. It's your application happily doing its thing inside its own perfect, isolated bubble. So let's put it all together in a super quick workflow. 1, you write your Docker file. 2, you pick a starting point, like a basic Ubuntu image. 3, you add some run commands to install whatever your app needs. 4, you tell it what command to run when it starts. 5, you type Docker build and poof, you have your perfect unchangeable image. And 6, you type Docker run to bring that image to life as a container. And the cool part? You can spin up hundreds of identical containers from that one single image.
So you've gone through those steps. What do you actually have at the end of it all? You've built something incredibly powerful, a universal software container.
And here is the grand prize. That little container you just made, it can run anywhere. Seriously, on your coworker's Mac, across a dozen different cloud servers, on the big servers at work, and yes, even on your friend's ancient potato of a laptop. As long as Docker's there, it just works.
And that, right there, is the promise of Docker fully delivered. It isn't just about making things easy. It's about ironclad reliability. Your app will behave the exact same way everywhere, every single time. The whole "it works on my machine" excuse? Yeah, that's officially dead and buried.
What this technology does is just erase one of the biggest, most annoying roadblocks in building software. It lets you stop worrying about weird environments and start focusing on what you actually love to do: creating, inventing, and building cool stuff. Which really leaves you with one big exciting question. Now that you can build an app that can reliably run anywhere, what are you going to build next?